All right, let's look at part C. We're looking at the area of the interior of r equals 4 plus sine theta. Okay, so please have your TI-84 with you and then start plotting r equals 4 plus sine theta. I'm going to use the same formula like I used for the other two cases, A and B. Essentially, you're looking at 1/2 r squared d theta, and the lower limit is alpha and upper limit is beta for the integral. So that means that your area is stuck in between the raised theta equals alpha, theta equals beta, and your curve. Okay, so if you started graphing 4 plus sine theta, you should be able to see something like this. It's a circle. It's a shifted circle. Okay, and you want to know what thetas cover the shaded region. Okay, or what rays sweep through this area, as you see, area of the region. Okay, so let's have this little table as the way we did in other parts of this question, theta and r. Again, once you graph this, it's not enough to see what thetas make this area covered. So you should sort of like look at this graph in a very educated way. Okay, so let's just do that. Theta equals 0. That's where we start. So this is 4 plus sine 0. That's exactly equal to 0. 4. I mean 4 plus 0 because sine 0 is equal to 0. So that's where I start right here. Okay. And now I'm going to choose theta equals, let's see, pi over 6. How about that? Pi over 6 is somewhere here. Okay. So, okay. You can also try pi over 8 is the way I put here. So these angles over there are just representative angles, just to give you some reference. Okay, so pi over 6, 4 plus sine pi over 6, and go ahead and either look at the unit circle I provided earlier, which is this one, right? Pi over 6. I need sine pi over 6. Here we go. Sine is the y-coordinate, the point corresponding to pi over 6 on the unit circle. That's 1/2. I go back and write here that this is 5 over 2. This is 4 plus 1/2, which is 9 over 2. Okay, essentially 4.5. Yeah, there we go. Okay, so this is this point covered. Let's try pi over 2 because we're still going in this direction. That's good. Nothing is extraordinary. We don't get negative values here. In fact, we won't have any negative values because sine takes the values in between -1 and 1. So we should be safe. This is 4 plus sine pi over 2, and that's 5. Okay, you can check that by yourself. And then at pi, it should be 4 plus sine pi, and that should be 4. Okay, so you walk like 4 units. 1, 2, 3, 4 on the ray theta equals pi, and you walk 5 units here on the ray theta equals pi over 2. And let's try 3 pi over 2 and 2 pi, and then you're done with this. Okay, 3 pi over 2. Because so far, we're going in this direction. We covered almost this much of the area. Okay, so if you just like start from theta equals 0, go all the way to theta equals pi over 2, this is the area that you cover. At 3 pi over 2, you have sine to be -1, so it's 3. And eventually at 2 pi, you have sine 2 pi 0, so 4. Okay, so essentially, so you also cover the full area of the circle by changing theta from 0 to 2 pi. That's good because we can go back and use the formula now for alpha starting from 0 all the way to 2 pi. Okay, all the way to 2 pi. And I'm going to take the square of this. And the rest is just the integration. Okay, rest is just the integration. And let me just integrate the indefinite version of that integral right here. Okay. And to achieve that, you have to expand this whole thing. Okay, the quantity squared term. So this is sine theta, cosine, sine squared theta d theta. Okay. So it's not hard to integrate 16 and 8 sine theta, but for this one, we run into another sine squared theta d theta type integral. So we're going to use the power reducing formula for that. Okay, so let's just use that. So 16 plus 8 sine theta plus cosine 2 theta, cosine 2 theta, it's 1 minus cosine 2 theta. Okay, let me just erase this first. And this is 1 minus cosine 2 theta over 2. Okay. Again, we use the power reducing formula to replace sine squared theta by 1 minus cosine 2 theta over 2. Now we can finish the integration here. So this is 16 theta plus minus 8 cosine theta. That's what the integral of sine is, negative cosine theta, plus theta over 2 minus 1/4 sine 2 theta, okay? Plus the integrating constant. Okay, so what I'm going to do next is I'm going to copy that down here, and maybe we can get rid of that separate piece of work. 1/2 16 theta minus 8 cosine theta plus theta over 2 minus 1/4 sine 2 theta, right? And we have the limits 0 and 2 pi. So we're going to have like two evaluations here. One for theta equals 2 pi, and the other one is for theta equals 0. Okay? So here we go. I'm going to continue with yellow. All right, so I'm going to plug in 2 pi. Okay, so this becomes 32 pi minus 8 cosine 2 pi. Okay, plus 2 pi over 2, that's pi, minus 1/4 sine 4 pi. That takes care of the upper limit. Minus 1/2 0, 8 cosine 0, plus 0 minus 1/4 sine 0. All right, let's see what goes away. So first off, well, this is 0, and sine 0, and sine 4 pi. They are all zeros, okay? And cosine 0 and cosine 2 pi, they're both 1, okay? All right, let's wrap everything up. 1/2, 32 pi minus 8 plus pi minus 1/2 times negative 8, so that makes it like 4, okay? If I am not mistaken, yes. All right, so you have another minus 4 coming from here because you have 1/2 times negative 8, that's negative 4. That cancels this 4 here. So eventually we have 33 pi over 2 for the area of the circle here, okay? All right, so I think that's almost the end of it. So area is 33 pi over 2. Now you can, in fact, calculate this area by using the area formula for a circle as well, because we have a circle with a different center. Obviously, it's not centered at the origin, so go ahead and check that by yourself. All right, this takes care of part A, B, and C all the way. I think we're at the end of this exercise, and thanks for watching. I'll see you in another exercise. Bye.